welcome back to another coding ASMR video. And today I'll make a little Java program that folds paper in half as many times until you cannot fold or stuff happens. So, and test the theory behind why you cannot fold a paper more than 7 times. So, before I begin coding, I have a sheet of paper and I'm folding it one time, and then another time, and then another time, and then another time. 4 folds, 5 folds, 6 folds, and yeah, I could barely fold this piece of paper 6 times. So, but here in this program, in this Java program, I'll try to allow myself to fold paper more than 7 times, or 6 in this case. So let's begin. Right now, I have a paper class in which I could create a piece of paper as an object. Not a real piece of paper, but a virtual piece of paper made from this class, which has certain properties. So I'm going to code some attributes of this paper. I have 4 attributes that my paper will have. I will have a length, so how long the paper is, as well as the width. Let's assume that all paper I can make are rectangle. And this is pretty important, in which will be why I can't fold paper more than 7 times. The thickness of the paper. And then this here is an attribute, an integer attribute of how many folds I have folded the paper so far. So first of all, it starts at 0, and then as I fold it, I will increase that by 1. So here's my attributes, and now I'm going to write my constructor once I create my paper. Okay, constructor. And before that, I'll write the units of measurement of how thick the paper is. So in millimeters. And then in centimeter, and no, let's just do in millimeters for now. And millimeters. And millimeters. In millimeters. Okay. So yeah. This is not a unit, so I'm going to do my constructor that can create my paper object. So yeah. So I have made a constructor here that I will input a length and width. So once I call it, I could define an integer, a value for the length, how long the paper, and how wide the paper. And it's going to set it accordingly. And I will set the number of folds to 0 and the thickness to 0.1 millimeters. So it's pretty thin, but it's gonna get weird as I fold the paper more. So I'm gonna make another constructor that will set default values. So A4 paper, that's the usual size, pretty common size, and I'm gonna make an overloaded constructor. If you do not know what overloaded constructor is, it's a constructor that has the same name with different parameters, and the computer will choose depending which constructor to call depending on the input values or parameters. So this one has no values, and I'm going to just set it to the default values. So for an A4 size, the length is 297. Millimeters. It's almost like 1 foot, and the width is 210 millimeters. So that's A4 sizes. And that's what if you don't have any inputs, and if you decide to put a length and a width, it's going to call that. If not, then just set it to the A4 default size. So I made these two constructors that creates paper objects, a virtual piece of paper. So yeah, before I begin, I'm going to make another method that folds the paper. So this method will fold the paper. This is going to be the method, that's the magic method that folds the paper in half. Let's call it fold in half because that's what we want to do to be more specific, to fold the paper in half. No inputs. So once I fold the paper in half, I'm going to show you the example here. So I fold this in half. Once I fold in half, the thickness will increase, will double. The thickness of the paper will double. Also, once I fold it in half, either the width or the length will become half the length. So it's going to have the length or the width depending on the direction you fold. So since I fold the paper, let's assume that I fold the paper horizontally or vertically. Either the width or the length will become half of that. And assuming that I fold in opposite directions, alternating horizontally and vertically, I'll make a fold. I'll have either the length or width depending on how many folds. So if like end folds, end folds. Let's say that paper has been folded an even number of times, the length will become half of that. So divide by, this means this notation is like a shorthand of this dot length equals like this here. This notation slash equals is like same thing as this length equals that. So that's a shorthand of like adding things, dividing things, multiplying things, or subtracting things to itself. So for even number folds, if this paper is folded an even number of times already, the length will be half, or else this dot length, the width, will become half of that. So that, just this method here, just folds the paper in half. And every time this paper is folded, the thickness will become twice as thick, and also either the length or width will become half. So this is a very important method. So let's try and print the paper. I'm gonna override the two-string method so I could allow myself to print the paper. So what I'm gonna do is that I'm going to print out the dimensions of the paper. So let's see, let's say string rep. Well, let's just return a sample string. Let's just return it for now, not make anything fancy. This paper is this dot plus concatenate with this dot with plus that plus in dimensions. It is currently. Alright, just put a new line. Like that. It is currently. Let's see. Is currently, let's see, print out this dot thickness, millimeters wide. Okay, so yeah. And also, it has been folded plus this dot and folds plus this the class here, and before that I have to increment my end folds. Don't forget the folds will go out by 1. And now I'm going to try to create a paper object. So this is my main class, and I'm going to create a piece of paper. Scrap paper, let's call it scrap paper. Equals paper. Let's name it scrap paper. Let's test it. Okay, so I've made my paper, and this paper, and it prints out the thickness, the length and width. This paper is 210 millimeters and 297 millimeters in dimensions. It is currently that 0.1 millimeters thick, and it has been folded 0 times. So let's try to fold it. Let's try to fold the paper. Fold in half and print. And print it again. Let's try it. So this is the paper before I fold it and after I fold it. Once I fold it in half, it becomes twice as thick. And then fold 1 time. Yeah. So this is how many, this is the thickness, and this one, the length or width, or I should say either, has been halved. If I fold it again, if I fold it 2 times, and I'll print it, look how thick the paper is, and it's gonna fold 2 times. So let's make this crazier. Let's make this a bit crazier. Okay, shall we? Let's do another method here that allows you to fold paper more than, not just once, but n times. In half. It's going to be method alone. And it's gonna do, it's gonna just loop it. Just do a for loop. Pretty quick. And it's just gonna keep folding in half until it has reached a desired amount. So if I just put a 1 here, I'll do, the paper will be folded in half 1 time. 2 means 2 times. 3 means fold in half 3 times, and so on. So yeah, I'm gonna try and go on my main, and let's try to call that method. Fold in half times. Let's try to do it 4 times, and let's see how to do it. If I fold it in half 4 times, this is how thick the paper would be, 1.6 millimeters. And this is how thick, how the length and width of the paper. If I do it 7 times, this is how thick it is. It's now 1 centimeter thick, 12.8 millimeters, and 7 times folded. So this is why I cannot fold paper more than 7 times. As I fold the paper in half, subsequently the paper will become smaller and smaller and also become thicker and thicker. But this is not what I wanted to do. I just want to do something else. Let's do this. Let's take it further. Let's not fold it 7 times. Let's try to fold the paper more than 7 times. Let's say like 100 times or 400 times. Let's see what's going to happen. So that's that. Let's see. So before that, actually, let's fold the paper more. Let's just keep folding it. Let's try it 10 times and see what kind of paper we get. If I fold the paper 10 times, this is how small the paper is. So it's going to be, if it's 6.5256, it's like really small like that. 10 times, pretty close to centimeter, and 102.4 millimeters thick. That is like 10 centimeters already. So it's going to be like this. It's become so small, it's going to act like you won't feel like a piece of paper, like a flat paper. It's going to be more like a stick, and not counting how the paper bends, which affects the size. Let's try folding it. Let's try to bump it. Let's try to fold it 20 times. If I fold the paper, fold the paper 20 times. If I do that, this is how thick the paper becomes. So let's not do that. Let's convert that unit as it gets so big. Let's try it in kilometers. If I do that, let's first take it one small step. Let's do meters. Meters and dimensions. So if I fold paper 20 times, this is how big, how thick the paper is, and this is how small the paper is right now. So let's do it more. Instead of doing that, let's just not care about the thickness, about the width, the length and width. As we already know, the length becomes increasingly small and small and small and small and small. Let's see how tall the paper gets as we keep folding it in half and turn it. As the paper becomes so thin, it's like a strip, like a very thin straw. Let's not care about the thickness anymore. The dimensions. let's try it one step further. Let's fold it 25 times. In fact, if we fold it 25 times, let's see how tall this paper gets. And pretty much it's 3 kilometers tall. Wow. That is pretty thick. And let's just convert it. Let's just convert that to kilometers pretty quick. And yeah, if we keep doing that, let's try 30 times now. 107 kilometers. That becomes like larger than like how wide a city gets. If we fold it 40 times, 40 folds, you can imagine how big, how thick, or how high the paper is. You see, paper, we don't at this point, we don't really know. We don't really call this paper thick, since the paper gets so small and becomes increasingly thick, it becomes a height. So it's almost as big as the planet of Jupiter. If we fold it 50 times, it becomes crazy. This is how big it is. I cannot even read this number. So imagine that, how big the paper gets. So let's try folding it 100 times. Let's see how big this paper gets, how tall this paper gets. 1.6267 times 10 to the power of 23 kilometers thick. That is like almost as big as a galaxy. If that I could do it. If I think I could compare that. Anyways, I'm not sure how I can compare this to another object or somewhere in space, but I know it's way past the solar system and maybe even the universe. So yeah, so that's the proof of how paper cannot be folded more than, let's say, 7 or 8 times in a Java program. Because as a takeaway message, paper becomes twice as thick as you fold it in half. Each successful fold, and every time the paper becomes half the width or length depending on the direction. And if you cannot fold it anymore, this is because the paper theoretically will not even look like a piece of paper. If you fold it more than 7 or 8 times, it's going to be more like a stick, a paper stick that keeps getting infinitely thin in length and width, and will just keep getting twice as high and eventually become the length or height past the universe. So this is the end of this video. It's a little bit of like a little story plus some Java coding. I hope you get some tingles. Drop a like down in the video if you do get your tingles, your dose of tingles needed or required. So have a good night, everyone, and stay tuned for the next lo-fi ASMR coding video.